What if we could reach the moon without rockets? No fuel, no boosters, just a cable stretching through space. It sounds impossible, but engineers have studied this idea for decades. It's called the moon elevator, and unlike a space elevator on Earth, this one might actually work. And before you click away, stick with me, because this idea isn't science fiction. It's real engineering research, backed by serious scientists and universities. You're watching Corecraft Engineering, and together, we'll explore how this megastructure could be built, the challenges it faces, and whether it could change space travel forever. The concept of a space elevator isn't new. Back in 1895, Russian scientist Konstantin Tsiolkovsky imagined a tower reaching from Earth into space, but Earth's gravity and atmosphere make it nearly impossible. The moon, however, is different. In the 1970s and early 2000s, NASA and university researchers, including Columbia University and later the NASA Institute for Advanced Concepts, ran detailed studies. Their conclusion? A lunar elevator might be the first space elevator humanity could realistically build. Why the moon, and not Earth? First, gravity. Earth's surface gravity is strong, 6 times stronger than the moon's. Second, the atmosphere. Earth has storms, winds, and weather that would tear a tether apart. The moon has none. Third, orbital mechanics. To escape Earth, a tether must withstand insane stresses, materials far beyond what we can produce. But on the moon, a cable made of advanced polymers like Xylon or carbon nanotubes might actually be enough. In short, the moon is nature's perfect testbed for this megastructure. So how exactly would a moon elevator function? Picture this: a massive tether, anchored firmly on the lunar surface, rising straight up into space. But here's the twist. It doesn't just stop in orbit. It stretches thousands of kilometers beyond, reaching past a special point where the moon's pull and Earth's pull cancel each other out. This is the Earth-Moon Lagrange point. Now you might wonder, what keeps the tether from just falling back down? That's where the counterweight comes in. Engineers imagine attaching a heavy mass, perhaps captured space debris, or even a manufactured station, far beyond the Lagrange point. Its outward momentum pulls the tether tight, like the weight on the end of a yo-yo string. Think of it like flying a kite. The moon is your hand, the tether is the string, and the counterweight is the wind keeping the kite stretched and steady in the sky. With the tether held in tension between the moon's gravity below and the counterweight above, the entire structure acts like a stretched guitar string in space. Robotic climbers could then latch onto the tether and crawl upward, hauling minerals, fuel, or even astronauts. Instead of guzzling rocket fuel, they'd sip power from solar panels or beams of energy sent from the moon's surface. No deafening rocket launches, no discarded booster stages, just a silent, reusable conveyor belt, linking the moon to the gateway of deep space. But how do you actually build something like this? Step 1. Materials. We need an ultra-strong, lightweight ribbon. Current candidates include Xylon, Kevlar composites, and experimental carbon nanotubes. Step 2. Deployment. A spacecraft rides a rocket from Earth to lunar orbit, then slowly unfurls the tether. One end lowers down to the moon's surface while the other extends outward, acting as a counterweight. Step 3. Anchoring. On the moon, robotic construction units could 3D print a landing pad out of lunar regolith, locking the cable firmly in place. Step 4. Stabilization. The tether balances between lunar gravity pulling down and orbital momentum pulling outward. Step 5. Test runs. Small robotic climbers would run first, checking strength and tension before larger missions begin. It's a process that sounds futuristic, but technically, every step is possible with technologies we're already developing. Of course, building the moon elevator isn't easy. Challenge 1. Materials. We don't yet have the ability to mass-produce carbon nanotubes or graphene ribbons at the required length, thousands of kilometers long. Challenge 2. Micrometeoroids. The moon is constantly bombarded by tiny, high-speed projectiles that could sever the tether. Solutions include multiple parallel strands or self-healing composites. Challenge 3. Orbital stability. The moon's gravity is lumpy, uneven across its surface. This could destabilize the tether unless corrected with constant adjustments. Challenge 4. Cost. Even if it's cheaper than rockets long-term, the upfront cost could run into hundreds of billions of dollars. But history tells us many megastructures once seemed impossible until we built them. So why even attempt it? Because the moon elevator could transform everything about space exploration. First, cost. Today, sending 1 kilogram to the moon costs tens of thousands of dollars. An elevator could slash this to hundreds. Second, mining. The moon holds helium-3, a possible fuel for future fusion reactors, along with rare earth metals. With an elevator, we could ship these into orbit cheaply. Third, a gateway to Mars. Launching rockets from lunar orbit requires far less fuel than launching from Earth. The moon elevator could act as humanity's first true spaceport. And finally, permanent lunar bases. With a stable supply line, the moon becomes not just a destination, but a second home. So when might we see this happen? Groups like Liftport, NASA and JAXA in Japan are actively studying the concept. Some predict a prototype tether could be tested in the 2030s, with a full-scale lunar elevator by mid-century. If that happens, it could be the single most important engineering project in space exploration, a literal highway between worlds. Not science fiction, not fantasy, but an engineering challenge waiting for us to solve. The moon elevator is bold, risky, and expensive. But if built, it could open the door to a permanent lunar economy and the first stepping stone to Mars. What do you think? Should humanity build the moon elevator, or is it too ambitious to ever work? This is Corecraft Engineering, explaining the genius inventions that could shape our future. Don't forget to like, subscribe, and share your thoughts below.